Thank you for that introduction, and thank you for the invitation. I think all of us have, the things that we think we do well and we would hope that other people would see, and it's always very nice when somebody does see, right? So, thanks. So, I want to talk about, so I use the large language models here as part of the hook. If you're hoping for a talk in which I tell you actually large language models are stupid, don't pay attention to them, this isn't this talk. If you're expecting like a booster talk, like large language models are amazing, they've solved everything, that's also not it. What I like about large language models is that they provide a comparison that, especially for language and a lot of sort of like higher level cognition, we often just don't have, right? So what are our comparison animals for language? I mean, people will look at songbirds and things like that, but let's agree that songbirds are doing something very different from what we are doing, even if they're doing similar things in some levels. Large language models produce behavior that looks an awful lot like us, and that makes them fun for comparison. So hopefully you'll see how that works. So language is a tool for getting a thought from one person's head into another's. I guess these people are very excited about basketball. By the way, this is not a huge screen, so I'm not going to apologize to the people in the back who could sit closer up for the size of font, but you may at some point decide you're going to need larger to move up, because there's a very deep room for the size of the screen. And as like a language acquisition researcher, what I'm really interested in is how babies learn to move thoughts from brain to brain with language, which is basically a decoding problem, right? So there's some thought, it's been encoded in language, and baby has to decode it on the other end. Today, though, I'm going to take a step back, which is ask what is actually in the signal, right? What is actually being encoded? Because to understand how children learn to decode, we actually need to understand what is this thing, language, that they are decoding. And what I'm going to focus on this is going to be my parade example here, is when we say something like Tyrone is a basketball player, what are we actually saying about Tyrone, right? So one hypothesis is that actually all the information that you're getting about Tyrone is actually in some important way encoded, like it's literally in the language, right? So, and this would mean that everyone who understands the words gets the same information out of that utterance. So, one version of this would be like definitions all the way down. Some people, of course, no problems with definitions. So, there's alternatives where, all right, here's a problem, right? By the way, normally I would probe, for these kinds, for my examples, I'd probe audience intuitions or have a throwaway, prolific study. It's a lot more fun to ask ChatGPT, so that's what I'm going to be doing. So I just asked ChatGPT, define basketball player. So the basketball player is an individual who participates in the sport of basketball, a team sport that is played on a rectangular court with the objective of scoring points by shooting the ball through the opponent's hoop or basket. It's not a bad definition, right? Okay, there's a question. Tyrone is a basketball player. Is he tall? Well, and I just want to remind you that in the definition we got here, it said nothing about height, right? Not in the definition, at least as far as ChatGPT is concerned. So ask, is Tyrone tall? I don't have any specific information about Tyrone, as my knowledge is limited and I don't have access to real-time data. Whether Tyrone is tall or not would depend on his individual height compared to the average height of basketball players. Basketball players can vary in height, with some being quite tall, while others may be closer to average height. If you have specific information about Tyrone's height or any other details, I could provide a more accurate answer. Okay, so, and this seems right? It's not part of, the meaning of being a basketball player that you're tall, but probably most people, agree that they probably assumed Tyrone was tall. This is actually Tyrone Muggsy Bogues, who is not tall, right? I believe he was 5'3", 5'4", something like that. 5'3", yeah. And he's, by the way, not like a, he actually played for a decade and a half, more than that, I think, right, in the NBA. He's the shortest professional basketball player either, and he's a real basketball player, not just like a bench warmer, right? And he's not tall, right? And actually, just to make sure ChatGPT really understood this, is it possible to be a basketball player without being tall? Yes, it is possible to be a basketball player without being exceptionally tall, which seems right. Is it possible to be a basketball player without ever playing basketball? Technically, it's not possible to be a basketball player without ever playing basketball, which also seems right. There's a difference here. It seems like there's some information that is if you here Tyrone is a basketball player and you don't infer that he plays basketball, you have fundamentally misunderstood the words in the sentence, but not knowing whether he's tall or short seems like something else. So people try like prototype theories of definitions. This is ultimately not, turns out the problems with those too, right? And you have to deal with like weighted prototypes. Maybe some things are more prototypical. Being a basketball player, like playing basketball, is very prototypical of a basketball player. Being tall is just mostly prototypical. You have problems with those too. So there's another approach that people have taken, which is that language is a conditioner on possible worlds. And if you're familiar with like formal semantics approaches, basically what I'm going to be describing to you right here. And what this means is that the message depends on what you know. So let's imagine some different possible worlds in which there is someone named Tyrone, right? In one, he's a basketball player, a short basketball player. In another, he's a tall basketball player. In another, he's a golfer. In another, he's an author. In another, he's a radio personality. And another, I'm going to go with funeral undertaker in this case. And then we take the sentence, Tyrone is a basketball player, that just eliminates all the possibilities, all the possible worlds in which he's not a basketball player, right? Problem is here, of course, we're solving this problem with why would we think that he was tall, because there's two possible worlds in which one he's tall and one in which he's short. We can make this, though, probabilistic, right? Because like some worlds are a priori just more likely, right? There's lots of ways to be a tall basketball player. It's sort of like a rare combination of skills that result in somebody very short being a basketball player. So this is what people often mean when they say possible world semantics. I'm just going to be specific and call it probable world semantics. So here the idea is, just thinking about like all the possible worlds in which he's a basketball player, there's probably a lot more in which he's tall, and not very many in which he's short. And so we, infer that he's probably tall, right? Because most possible worlds in which Tyrone is a basketball player, he's also a tall basketball player. And that means that the meaning of a sentence like Tyrone is a basketball player is in some sense like an integral over the possible worlds. All right. There's another thing that there's no clean transition here. I'm just going to get something else out on the table, which is all the way along, so far I've assumed that the words themselves were unambiguous, which they're not. So there's a nice example. Students cook and serve grandparents. Newspaper article headlines are great for this. So like, more time granted to murder police. And actually, probable world semantics can actually handle what's going on here in a very natural way. But we're going to need to add a very simple model of listeners' beliefs about speakers. To get there, if you love Gricean pragmatics or something like that, I'm going to ignore that sort of recursive reasoning entirely. We're not going to need it for anything that I talk about, although I'm very happy to talk about it later. So here's our generative model. So this listener's belief is that utterances are a function of some message that the speaker wanted to convey, and the rules of language, right? So they have to use the rules to produce a sentence that is compatible with that message. Now the message itself comes from is driven by the speaker's knowledge and their intentions, right? They wanted to tell you, they knew something and wanted to tell you about it. And their knowledge, of course, is a function of what's actually out there in the world to know and what their experience with the world is. But we've just been looking at sentences on a screen. There's no actual speaker here or any particular one, so we have no specific beliefs about their intentions. We have no specific knowledge about their experience. So all else equal, what this ends up meaning is basically things that are more likely to be true of the world are also more likely to be things the speaker knows and wants to tell us. We can get quite far with just that. All right, so by the way, this is so just like in Bayesian terms, the probability of the message given the utterance is proportional to the probability of the utterance given the message, right? The probability you actually use that sentence to convey that particular message times the prior probability that you would ever want to tell somebody that particular message, which again is just more likely if it's something that might actually happen. So let's think about students cook and serve grandparents, right? So one possible interpretation is there are cannibalistic students out there. And so probably the message is about cannibals, given that this was the message, is the probability that this is the article you would see if there were cannibalistic students out there. And let's say maybe it's like 30% probability. I don't know. But probably the prior probability of cannibalistic students is quite low. It is probably an overestimate. And so altogether, we think there's a 0.3, so unnormalized 0.3% probability that students are eating their grandparents. As opposed to the probability the message is about some good kids, cooking food for grandparents. All right, well, like if that was what was going on, maybe there's even a higher chance that this is actually the newspaper article you get. Because, by the way, the reason I think this is only about 30% is I think if there were actually cannibals, it'd be like, oh my God, cannibal students eating grandparents, right? And then the prior probability that there's some nice kids somewhere helping out grandparents seems decent, right? And what matters here is the ratio of these two probabilities, right? So it's just much more likely that you would have seen this message, this like article, because of good kids than because of cannibals. So score 1 for probable world semantics. But you might wonder, what about large language models? And what's interesting about large language models is they probably have no distinction between language and sort of like broader world knowledge. It's certainly not how they're trained. Now, granted, nobody actually understands how large language models work, so who knows? But at least in terms of how they're set up, they are not meant to distinguish the two in the way I've just been describing. I've already shown you that ChatGPT actually knows the difference between entailments and things that are not entailed, right? Basketball players aren't necessarily tall. It's actually asked, and probabilistic facts, right? What about our ambiguity problem? So I told it I read a newspaper headline that says students cook and serve grandparents. Does this mean they are cannibals? No, the headline you mentioned is likely not suggesting students are engaging in cannibalism. Newspaper headlines can sometimes be misleading or unclear due to space limitations. It could be related to a cooking or culinary event organized by students for their grandparents, a community service project, or some other non-cannibalistic activity. So does this mean we don't need, probable world semantics, right? It looked very nice, made sense to philosophers, made sense to linguists, but actually we don't need it, right? Well, one possibility is, of course, that there's more than one way to interpret language out there. Humans happen to use probable world semantics, but it's not the only option, right? Large language models have found another way of doing this. Another possibility is that it's actually just probable world semantics seemed like a good theory, but it's actually just not what people are doing. And I'm going to focus on something called Winograd schema to investigate this possibility. So name comes from this 1972, we call it a paper in cognitive psychology. It is technically an entire issue. It is just like, honestly, I've never read it. It's really, really long, but it's supposedly very, very good. And in particular, one of the things that people have been interested in were some examples that he came up with. Like, the city council denied the protesters a permit because they feared violence. And here it seems like the people fearing violence are the city council. The city council denied the protesters a permit because they advocated violence. Seems like it's the protesters who advocated violence. But of course, it doesn't have to be that way. So you can sort of concoct a situation in which, like, some city council wants to stir up violence in the streets in order to justify an authoritarian crackdown, and so they're denying a permit to ensure that there will be some sort of try to stir up a riot, right? And so what Winograd points out here is it seems like basically anything and everything you know about the world could potentially play a role in a very basic linguistic process like interpreting a pronoun. And pronouns are absolutely everywhere, right? So this century, Winograd schema emerged as a major topic in cognitive science. So there was this Winograd schema challenge originally proposed by Hector Levesque, and picked up by Gary Marcus and Ernie Davis especially. And the idea here was that, the imitation game, the classic Turing test is nice, but it's not great as a target because incremental improvement is very hard to measure across models, right? Chatbot either succeeds at convincing you it's human or doesn't, right? You can have maybe 5,000 humans all try to judge that chatbot. Now you have sort of a probabilistic scale of how successful it is. But these sentences, it's just interpreting a pronoun. It's a very clear, correct answer. And you can generate lots and lots of these sentences, so now you can actually have a test that you can get a score on, right? And say, oh, this model got 87% correct, that one got 89%, and try to understand why. So actually, there is one official Winograd Schema challenge. It is one of the tasks in the Superglue scoreboard, which many of the major models have been tested against. One thing to point out is, oh man, so some of these models are doing really well, right? So, close to 100% correct. So you get these articles like The Defeat of the Winograd Schema Challenge by Ernie Davis and Gary Marcus and others. And they concluded that actually maybe the Winograd Schema Challenge was actually easier to beat without really being intelligent. You could have concluded that, okay, LLMs are intelligent. That's not what they're going to conclude. They conclude maybe it just wasn't that hard after all. Obviously, since I'm here giving this talk, it's probably not the conclusion I'm going to come to. Before going forwards, I want to just say I'm going to be comparing in this talk to one specific model, and not GPT. So actually GPT, so this is like leaderboard in just the Winograd Schema Challenge. That's GPT-3 at the bottom. GPT-4 is actually not much better. We're going to use T5, which is much closer to the top. There are models that do a bit better, but they tend to have less nice interfaces to work with, or were less well documented. So T5 was not easy to work with, but the easiest, and so that's what we'll be using. And again, what's going to matter to me here is not that, this is the very best, large language model out there for Winograd Schema, or that it is impossible that any model would ever succeed at Winograd Schema. I'm just interested in, here we've got a really good one that does a really good job on a lot of language tasks, and we're going to try to probe that a bit and compare it head-to-head with our probable world semantics. So in evaluation 1, I'm going to call it Tug of War World in Marble Land. It'll be sort of obvious why in a moment, right? So we have a little world in which there are two people playing tug of war. Let's call them Al and Bart. And you can say things like Al beat Bart at tug of war because he's strong. Seems like this is probably, the strong person here is probably Al, right, or A. Al beat ABB because he's weak. The weak one, the he there is probably B. Al lost to B because he's strong. You would just keep on moving these around by switching up sentences a little bit. We also do didn't beat, didn't lose to, flips all the intuitions. We can do almost beat, moves things around. A beat B although he is strong. Right now it seems like B is strong, but A beat him anyway. So you can get 32 sentences by just flipping these different bits. And then Marble World is very similar. We have Marble A knocked Marble B into the pocket because it's heavy or light, or blocked A blocked B from the pocket because it's heavy or light. And again, just do the same almost, didn't, etc. And we get 32 more sentences there. So just for historical comparison, for people who are interested. There were older theories of pronoun interpretation. So actually, the leading one even into this century was probably centering theory, which it's a little bit more complicated than this, but you can just gloss it as pronouns preferentially refer to the subject of the previous sentence. In most cases, that's what it ends up meaning, which you'll notice that sort of this fails horrifically on Winograd Schema. This is how the Winograd Schema are designed. And actually, the state-of-the-art pronoun reference resolution system back in the early 2000s was well below chance on a two alternative force choice because it actually just used centering theory. So I take those sentences that I had before. I've gotten humans to judge the pronouns. And I'm going to just see how centering theory does. Centering theory has a couple free parameters, and I'm going to talk about them unless somebody gets really into centering theory later. I'm just going to fit the free parameters to the data. And here we have log odds, human shows the subject. Here we've got log odds, human. The centering theory thinks the pronoun refers to the previous subject. And technically the correlation's not actually zero, it's undefined. But it's sort of asymptotically zero. Again, these sentences were designed to, be impossible for centering theory. So that's, sort of gives us a nice baseline. There's this other sort of really picked up in the 21st century is this heuristics or expectancy hypothesis, mostly associated with Jennifer Arnold and Elsie Kaiser, a few people like that. I've sort of like poked around in that space from time to time, and you could interpret some of what I've done as being, in this context. And the idea is that pronoun refers to the most salient antecedent, the most salient thing that you could be talking about right now. And different things make, potential reference be more salient, like having been a subject of a sentence, or maybe, being an agent as opposed to a patient. This may be modulated by connective. It depends if you're saying, something because something, or something although something. So there's a few like commonly discussed predictors, and we basically threw them into a linear regression and just fit that regression to see how well, in the best case scenario, how much of the, the data could be explained, and not much, right? So for these Winograd schema, at least, like these are the most popular, theories in psycholinguistics, I think, still now, and just fails miserably on Winograd schema. A little bit better than centering. But again, we're really overfitting to the data. Now, if you're wondering, the heuristics models weren't really designed for Winograd schema. I will show you a case later where they're being applied to something they were designed for, and they will do better there. Now, what about probable world semantics? Well, okay, we have A beat B because he is strong, right? And so let's see how we would do this in probable world semantics. So A beat B because A is strong, or A beat B because B is strong, are the reasonable interpretations here. I'm not going to worry about A beat B because C is strong, because obviously that just couldn't be the case. And this is actually in the model, but I'm just not going to talk about it unless somebody really wants me to. I'm going to use assume because means something like cause, right? So this means something like A being strong caused A to beat B. All right? It's a reasonable interpretation of because. And I'm going to use a counterfactual semantics here. So this means something like, A beat B, but if A had not been strong, A would not have beaten B. Now, there are a number of theories of causal reasoning out there. Not all of them are purely counterfactual like this. One of the interesting things about theories of how people think about causation is they tend to make the same predictions for sort of run-of-the-mill stuff, and it's in the really interesting edge cases where they pull apart. Well, we're not working with interesting edge cases here, and counterfactuals are much easier to calculate, which is why I'm going to use it. But there's no reason that it should really make much of a difference here. And I haven't looked at those edge cases. But this seems right? So, it seems likely to be true that, the statement that A, beat B, and if A had not been strong, A would not have beaten B, seems like that's something that could plausibly be true of the world. Whereas on the other side, you end up with, A beat B, and if B had not been strong, A would not have, and B is strong, but if B had not been strong, A would not have beaten B, which seems exactly backwards, right? If B was weak, they almost certainly would have lost. And this is what we want. We wanted, this statement here to just be a priori more likely than this statement here, giving us, why we choose this interpretation over this interpretation. Okay, so now we actually have to get numbers for how likely those events are. So here's our model of tug of war. People's strengths are normally distributed, which they more or less are. And I'm going to play it. So we're going to have a sort of prototype semantics for gradable adjectives. Please don't kill me. Where basically weak means sort of close to the prototypical strength of a weak person, which is actually 1 standard deviation below the mean. So we did it. Strong is 1 standard deviation above the mean, is be maximally strong. Any more or less than that, you're less likely to be called strong. This is wrong as a theory of semantics. But again, and here there's actual papers on this, the various theories of gradable adjectives, when you turn them into computational models, they tend to give the same predictions for sort of run-of-the-mill stuff like what I'm dealing with here, and they're different when you get into more interesting edge cases. We're not dealing with edge cases, and this turns out to be really easy to calculate with. And I'm going to make another simplifying assumption, not in the model, but just for exposition, which is the strongest player always wins. In the model, it's actually probabilistic. The stronger player beats the weaker player, in probability proportional to how much stronger they are. But it'll be easier to explain it not that way. So first thing we do is we draw a strength for A, conditioned on A having been strong, so probably somewhere close to the prototypical strength of a strong person. And we know that A beat B, so we draw a strength for B conditioned on A beat B, which means B must be weaker than A, right? Because otherwise A would have won. And so, maybe B is somewhere near the, middle of the distribution, or maybe a little bit to the left of the middle. So now we have the counterfactual. What if A had not been strong? Well, so we're going to redraw A, conditioned, call it A prime, conditioned on A not being strong. So maybe in this case A prime is still stronger than B, and A prime still would have won in this case. But in most of these cases, A prime is going to end up being weaker than B, and B would have won. And basically the proportion of samples in which A prime would not have won is our probability of that counterfactual. It's the probability that if A had not been strong, A would not have won. And we're just going to rerun this simulation a bunch of times in order to get a probability. What about B being strong? How likely is it that B being strong would cause A to beat B? Well, again, we draw a strength for B, conditioned on B being strong. But now, when we draw A, we know A beat B, so A has to be even stronger than B, which means A has to be actually quite strong. Now when we do the counterfactual and ask, well, what if B had not been strong? Well, basically in all those cases, B is going to be weaker than A and lose. So it's just not the case that if B had not been strong, A would not have beaten B. Now that probably is going to be very low. All right, so we get those probabilities out, we plug it into that little model I showed you before. Here is, and we're not doing any parameter fitting here at all. Here is the humans, their probability and log odds that that he referred to A as the model's log odds. You can see it's quite close. We can play the same game with weak and basically all these other sentences. And we do something very similar for marbles here. We just actually I just programmed up the Newton's laws, and we can just see based on different heavinesses of marbles how likely it is that A would not be into the pocket, right? So now here is again without any fitting the comparison between again humans on the x-axis and probable world semantics on the y-axis. We get a correlation of 0.94, so we're really explaining most of the variation here. So conclusion: language is now solved. As long as you only talk about marbles and tug of war, and also what about LLMs? Unfortunately, I don't have an LLM graph for this particular evaluation because remember how I said that T5 had this really nice, interface and with really good documentation, and we did all of the evaluations except for this last one, and it broke and doesn't work anymore, and it's no longer supported. So I have to But luckily, in the meantime, it has been implemented in Hugging Face, so we'll be able to get the numbers out. I just haven't figured out how yet. So evaluation number 2, we're going to look at a bigger world, right? Because we don't want a theory of just tug of war and marbles. So I created 40 pairs of cause discourses, and these are really based on, I said I had a lot of prior work on pronouns in psycholinguistics and sentence processing. We have sentences like Agnes frightened Beatrice because she is reckless. Agnes frightened Beatrice because she is timid. Probably get different pronoun interpretations there. We have discourses that are about consequences. Because Agnes frightened Beatrice, she got in trouble. Probably Agnes. Because Agnes frightened Beatrice, she ran away. Probably Beatrice. Or then there's just something happened and then something else happened. Call them continuation discourses. Agnes frightened Beatrice, then she frightened Carl. Agnes frightened Beatrice, then she got angry. You can come up with who you think the pronoun refers to there. You may have noticed that, now where are we going to get these probabilities, right? Because the probability that Agnes being reckless would cause Agnes to frighten Beatrice. The probability that, Agnes frightened Beatrice, the next event that would happen would be, Agnes frightened Carl, or Beatrice frightened Carl, or whatever, right? So be really nice if, let's start with centering theory. Here's again, centering theory, can't do this at all because same reasons as before. Heuristics has a decent correlation, but when you actually look at that figure, it really doesn't look like the heuristic model is doing well at all. Here is T5, right? So the large language model I'm working with has better correlation, right? But one of the things actually interesting is it's much more certain about what it can get very, very certain about who the pronoun refers to in a way that humans just don't. but I don't know. I don't know how like T5 is doing these probabilities. Like, or I actually know what T5 is doing in terms of probabilities. I don't know what happens when we ask people on prolific. How likely is it that that the pronoun refers to Agnes or whatnot? That the probabilities they're using really match what T5 is doing with probabilities. So worry less about the axes. But in any case, correlation's okay. Now, you might remember we need, for probable world semantics, we need probabilities of things happening in the world. So this is, of course, where I trot out my complete model of the world and how people think about the world, which is called asking people on Amazon Mechanical Turk how probable various things are to happen. Right? So again, we're not giving the pronoun sentences, we're just saying, Agnes frightened Beatrice, how likely is it that this would cause Agnes to run away? And we get probabilities from that, plug them in just where we would have plugged in probabilities from our tug of war model, and get our predictions. And this, does by far the best of our options here, of the different models. But again, it's not like the LLMs are doing badly. So we're going to keep on playing with this a bit, trying to make it a little bit harder. So compare the king fired the butler versus the butler fired the king. Hope we're all on the same page here. Butlers generally don't fire kings. That is like an a priori unlikely thing to happen. So we have been looking at sentences like, because Agnes angered Bartholomew, he fired him, right? And there, people interpret that he as being Bartholomew. Bartholomew's mad, he fires Alfred, right? Watch what happens when we do, because the butler angered the king, he fired him. Oh no, that's okay, right? So king fired the butler, that seems good. But what about because the king angered the butler, he fired him? Probably our intuitions are a bit weird there, right? But certainly it seems less obvious that he refers to the butler in that case, just because butlers don't fire kings. So we had 110 sentence pairs that are like this, sort of like of that format, where it really matters which character is doing what. And we're just looking at, sort of like how much does that manipulation matter, right? Are people sensitive to that manipulation? In centering and heuristics, like those theories just like don't address this at all, so of course they show no effect. Humans show an effect, and pro-world semantics and T5 actually show larger effects. But again, we can interpret the absolute magnitude or not. Either way, it certainly shows that pro-world semantics and T5 are both sensitive to this thing that humans are sensitive to, which is nice and seems kind of sophisticated. All right, now I had promised you that I was going to look at some cases. So we've been looking at cases where centering theory and heuristics do really badly, right? So in Winograd schema, they're just not designed for that. We're going to actually now look at some cases where they're actually whether they are designed for the thing. So this was 1972. Why? So 1974, Alfonso Karamazza and Catherine Garvey didn't actually use this sentence, but they wondered essentially what would happen if you just had no information after the pronoun there, right? So city council denied the protesters a permit because they. Turns out most people think that's the protesters, right? Even not knowing what comes next. This is called implicit causality, and sort of kicked off all this psycholinguistics work that I was mentioning. So we actually took those same sentences we had used in evaluation 2, like those 3 sets of 40 pairs, and just cut off everything after the pronoun and asked our different models and people who the pronoun referred to. Centering still can't do that. But heuristics actually does decently well. Of course, these sentences were designed, these are the sentences that heuristics theory was designed for, so that's not shocking. And again, this is actually a linear regression here, so we are overfitting the data definitely. But T5, at least in correlation, still correlates pretty well, right? So it's still able to do this thing that it was definitely not, designed to do. For pro-world semantics, we now actually have a problem, right? Because we have to decide the probability of the statement, the city council denied the protesters a permit because they. Right? We have an incomplete statement. So what we're going to do is have to integrate over all possible continuations of that sentence. And this is how we did that. So take a sentence like Agnes frightened Beatrice because, and we just ask people on Turk again to produce continuations involving Agnes, like she had an intimidating personality, had jumped out, had just killed someone. And we ended up picking sort of like the 30 best, which is a very they generate hundreds of these and some were crazy. And we just looked through for patterns, things that got repeated a lot of times. And then beyond that, picked ones that seemed nice to me. The goal here was just to have the particularly high probability ones, because we don't really have to worry about low probability continuations. They're not going to add much to the integral. And then we get, Beatrice-related continuations. Beatrice didn't see Agnes. Beatrice went into the haunted house. Beatrice is prejudiced. And again, we get 30 of those altogether. Now we're going to get another set of subjects to go through and rate the probabilities of these events, right? So Agnes had an intimidating personality. How likely is it that this would cause Agnes to frighten Beatrice? Agnes hid and jumped out. How likely is it that this would cause Agnes to frighten Beatrice, etc.? So you get probabilities for all of those sentences, so for all 30 Agnes sentences, and we add up those probabilities. We get probabilities for the 30 Beatrice explanations and add those up. Those are our probabilities now, right? That is integrating over possible continuations. We get the total, estimate of total probability of Agnes and Beatrice-related causes. And that actually does about as well as T5, as hacky as that was, it does as well as T5, right? And they're, not much behind heuristics again, right? So this, probable world semantics handles the stuff that heuristics does well, and things that heuristics doesn't do well. Now, though, we're going to get to the really important evaluation, and then I will be just wrapping up after that, which are fantasy worlds, right? So if my story here is right, that you are, you have some sort of generative model that generates possible worlds or likely worlds out there, and you condition it based on sentences. If I change your beliefs about how the world works, that should change your interpretations of the pronouns, right? It should change your interpretation of what was actually said. So, so remember back this corollary of the hypothesis one, it's all in the language. Everyone who understands the words gets the same meaning. Here, again, the message depends on what you know, right? Different people who know different things will interpret pronouns differently, or if we futz with what you know, you'll interpret it differently. So, new experiment. This tug-of-war tournament is taking place in ancient Troy. The Trojan god Adynamo is the god of the week. Tired of strong people always winning at the yearly tug-of-war tournament, he has decided to intervene this year to make sure that in every match the weakest wins. Because he's a god, he can make that happen. And then we have the same sentences that we used before for tug-of-war. And so how do we do the model? Well, we just do the model, but with the new rules, right? So again, before we had, A being strong, this is how we did it before, right? So in Troy world, the strongest player loses, right? So A being strong caused A to beat B. We draw a strength for A. Now we know A beat B, so A is weaker than B, right? And now we do the counterfactual. What if A had not been strong? Would A have still beaten B? And actually, in this case, A would have, because now A would be even weaker than B. And remember, now the weakest person always wins. So we get a complete flip in what is likely to be true of the world, and that should then flip who the pronoun refers to. So just showing you in humans, here was the data from evaluation 1, call it the factual world. Here's data from the counterfactual world. So here's what we get. Looks pretty good. Certainly they're paying attention to this manipulation. Hopefully we can agree about that. You might wonder what's going on there. Well, this is actually something we didn't think about when we designed the study. It has to do with what happens with although. And I haven't told you how we modeled the semantics of although, and it's actually shocking how little has been said about it in the linguistics literature. So for although, so A beat B, although B is strong, we draw strength for B, condition on B being strong. Now we know A beat B, so in the regular world, this means A is stronger than B, right? And now although means that sort of A beat B, but although B is strong, means something like A beat B, but sort of like the normal course of things, you wouldn't have thought that A beat B precisely because B is strong. All right, so we're just going to redraw strengths for A now, not conditioned on the fact that A won, but just based on other things we know about A, which is nothing, right? And actually, most of the time, if B is strong, most of the time A won't win, right? That seems like what we want, right? A, B although B is strong. Right, so in Troy world, strongest player loses. So you might think like everything just flips here, but actually what seems to be happening with the humans is that they're taking that although to target like the normal course of things would be not in Troy world, where A dynamo is not intervening. A beat B although B is strong, it means something like A beat B, B is strong, but if A dynamo had not been intervening, right, something different would have happened. So anyway, when we model that, it actually, like you can see, it fits really, really nice. Like it has the same results very nicely. T5, what's going on here is T5 is just ignoring the prompt. It just doesn't care, learns nothing from it. Here's, again, like comparing like model to humans. You can see like, it's a nice relationship for our model. T5 is just, can't do it. We had another version where we started with ignorance. So you're watching college students play tug of war in a tournament between two schools, Willowbrook College and Pinehurst University. A beat B because he's from Willowbrook College. Now, I don't know anything about these places, right? Then halfway through the study, we tell people, oh, by the way, students from Willowbrook College are generally strong. At this point, is from Willowbrook College should mean something like is strong. So here I'm just showing you for humans. Here we have the, black here is before they've been told, what that Willowbrook College students are strong. And we have just, chose, the likelihood the pronoun refers to, the subject in this, because in these sentences with is from Willowbrook College, and here is from, because they're strong, right? So before you know anything about Willowbrook College, like there shouldn't be a relation. It actually turns out to be an anti-relation. I have no idea why. But once we tell them that Willowbrook College students are strong, you get this nice positive correlation exactly like you would expect. They're treating that sentence, Willowbrook College, as if it were the same thing as saying that somebody is strong. So this is probable world semantics, gets a lot of that, right? It doesn't have this weird anti-correlation that I don't understand. T5, again, just ignores the information, right? It just doesn't update its beliefs at all. Or it updates its beliefs, but is unable to use that information. And again, here's just, the human to model comparison. So, in probable world semantics, right, a sentence is a Bayesian conditioner on possible worlds. How it updates your beliefs depends on what your beliefs are, right? And this seems to capture some, really key facts about human language interpretation. And LLMs, at least as exemplified by T5, succeed, but they're succeeding probably by doing something else, right? Because it seems that, particularly in the cases where, your sort of beliefs about the world matter are particularly where it's not, the T5 was not matching human intuitions. I think that's really interesting, right? Because it, means that there seems to be like a way of like getting pretty far in language, understanding that is probably different from what we're doing, and I think like illustrates like really the power of probable world semantics as the basis of a communication system. Now, of course, it is possible. What's going on here is LLMs just don't distinguish semantics from world knowledge, and because of that, when we update the world knowledge, just like things fall apart. It could be that the world knowledge isn't an integrated theory. So here I'm think a little bit about like a knowledge base, which is something people in AI used to work with. It's like a collection of facts. They don't have to be coherent. And a lot of the work in a knowledge base is there's all these things that you can think of as like a whole lot of tools you have in your toolbox. You do something, you go to your toolbox to get some tools, hopefully you grab the right ones. But like if you just forget to get the right tool out, you're going to not succeed in fixing the chest of drawers or interpreting your sentence. Or it could be that LLMs actually have somehow inferred something like a generative model of the world, and they are doing probable world semantics. That's why they succeed so well on a lot of cases, but they just have a difficulty updating that generative model. in real time. That's also possible. Again, as I said, we just don't know what large language models are doing, so it's hard to know for sure. What I do think, though, this again illustrates is that flexible use of your knowledge about the world really seems to be important for really core parts of language understanding. And you told me 40 to 45 minutes, and it was 44 minutes since I started. So look at, I'm really good at this. All right, and I'll take questions.
I'll let you take your own.
Okay, sure. Everybody's just dumbfounded. Yeah, Mark.
Just picking up on this last bit, do large language models have problems with conditionals in general?
I don't, this just changes so rapidly, I don't remember. Does somebody else here know that? Anybody paying attention?
You can imagine, okay, so it's a sort of an ordinary linguistic task to have antecedent, conditional, etc., and there would be plenty of things. It would seem like they wouldn't do so well if they couldn't reason about conditionals at all.
Well, I think I think they are pretty good at logic in general, where they don't. I mean, what we're really doing here is we're changing facts about the world that are not in the sentence, right? So this would be if you strike a match on a matchbook, it'll light, right? Seems likely to be true as long as you assume there's oxygen in the room. But if you say there's no oxygen in the room, I guess I would predict that the LLM might fail, except for actually in that particular example, it'll probably succeed, particularly if it's GPT. So there are something that a lot of people are just not aware of with GPT in particular, and a lot of the more recent models. And this is actually one of the reasons we focused on T5, is that the original transformers was all bottom-up learning, right? That is not the case anymore. So the difference between when we get past, I think GPT-3 has this, certainly by 3.5, there's an enormous amount of supervised learning. So you actually, give GPT a prompt, it returns a response, and then somebody probably in Kenya, gives a thumbs up or thumbs down for, a quarter of a penny or something. There's this enormous, sweatshops doing this. And in particular, one of the things they've been doing is systematically going through the entire cognitive science literature and putting in all the stimuli, right? And then training it to give the right response in every single one of them. And I just remember this, when ChatGPT, so I've been working on this for a bit, and then ChatGPT came out, and it was failing on my tug of war, actually on the Troy scenario. But then there was an update, and suddenly it succeeded, and I was like, oh crap, I'm gonna have to think of a new hook for that paper that I'm working on. And Josh Tenenbaum was like, did you use the exact same stimuli you used before? And I'm like, come on, it was just in the only place I had an AMLAT poster a few years ago. There's a PDF of the poster on my website, but there's no way, that wouldn't have been in their training set. And he's like, just try changing the names of the characters. And it fell apart, right? It couldn't do it once I changed the names. And this is actually really, really common. So a lot of those early results in GPT-3 are oh, it can pass Sally Ann tasks. Yeah, as long as they're called Sally and Ann, change the names and they'll suddenly fail. And I think this is important, certainly for thinking about, how we interpret. And so first of all, there's the confound issue of if you're using something, if your stimuli are something that GPT could have been trained on, it probably was trained on it, and so the stimuli are no longer useful, right, for testing GPT. But I think the fact that there's enormous amounts of supervised learning is also relevant, because I think a lot of people are still treating, ChatGPT as an example of a purely empiricist bottom-up learner, and it's just not anymore. T5, however, is, which is one of the reasons that we use it. Or actually, for people following the details, we take the original pure bottom-up transformer, then we do train it on answering pronoun questions, not any Winograd schema, but just sentences with pronouns, and we teach it to, please return a noun phrase that you think is equivalent to this pronoun, and you train it on about a few thousand pronoun sentences, and that's mainly just teach it to do the task. Because otherwise, like out of the box, it has trouble with the task. I don't remember who I saw. I think I might have seen you earlier.
Just a comment about counterfactual. There was they've done very well with programming tests that were in the data that it was trained on. When they tried something that was after the deadline, it failed the programming exam. There was a paper by Doug Leonard and Gary Marcus where they talked about giving what is the gender of the first woman president. I'm only trained until 2022. I don't know that. What is the gender of first? What is the religion of the first Jewish president? I can't answer that either. Basic understanding of things that they're not true right now, but possibly true. We can't answer.
Yeah. So actually, one of the reasons I have actually data for ChatGPT for a lot of these sentences, but it's like sort of uninteresting because a lot of times ChatGPT just like after they did that update, a lot of times it just responds, "I'm just a chatbot. I do not know the answer to this question," which is like true because these are actually technically ambiguous sentences. That's a reasonable response. It's not the response humans give, and it's completely useless for comparing to humans. But anyway, no, I think people vastly underestimate how much the training set has been contaminated. Right, in terms of having the answers to the questions you were asking in there. And GPT-4 is trained on what is like over 1 trillion words now. I mean, 3 was on 500 billion. And I just have no intuitions into what, like usually you say like, oh, well, there's no way it ever saw that in the input, right? You don't just, I just don't have intuitions about 500 billion words, right? So, people are all very impressed in ChatGPT could, produce, a synopsis of Winnie the Pooh in the style of, in the style of the King James Bible. Are you certain that is nowhere on any blog anywhere? Because I'm not. The internet is very large. Yeah.
Great talk. I was recently looking at some of this old Tversky stuff on A is similar to B constructions, and finding that it looks like it's asymmetric. Because there's like a figure ground structure that just the syntax composes where A is the figure and B is the ground. So North Korea is similar to China, gets graded as more true than China is similar to North Korea because China is a larger and more significant. So it's basically this is like a better ground. So one question I had is, do you see effects like that on this kind of pronoun binding in language models? I mean, I don't know, and also I guess was that sort of effect built into what you were calling the heuristics models?
No, I do not think so. Whatever kind of heuristic literature. So that kind of effect is, remember when I said earlier that I'm going to ignore like Gricean reasoning and sort of like recursive social reasoning? That's an example where we probably would need it to get like those figure ground effects, right? I think that's not something that out of the box like this probably world semantics model will handle. The part of the reason I don't have like Gricean reasoning, so some people will know like sort of like the best model out there is either Rational Speech Acts or Michael Franke has a very similar version called something else. They work roughly the same way. They are not tractable at all. There's a reason when you see like the studies, it's always what word would you use to which of these 2 words would you use to describe one of these 3 objects? Because when you get past that, it's intractable. Because you have to worry about so many alternatives, right? Because all the reasoning is about like, well, what else could you have said in this case? People have been making some progress on this. So what they actually do is constrain that the stuff I've seen that has like worked kind of well is they actually they train a neural network classifier to basically find like the words that people are most like in a context sort of like context free way, most likely to use to describe something in a particular situation, right? So you might call, you have these like colored, circles and squares, and you're likely to say blue or square or something like that. And it just like that ends up being the entire hypothesis space of possible terms you could use here, which actually sounds an awful lot like the scale, like the horn scales, and sort of like classic scalar implicature stuff. I think like that kind of reasoning has been really successful at addressing a lot of things. I don't know if anybody's done it with figure ground, but I suspect it probably would be able to. It's just, again, there's a tractability problem, and because I wanted to compare to large language models, I needed something that I could, apply to worlds that were at least as big as Tug of War, right? And ideally much bigger. Yeah.
I thought that was great. Thank you. I'm interested in language acquisition, and so I'm curious, what does this predict about what would happen in a scenario where I actually had very little knowledge about the world, right? So if I'm a kid, for example, and I don't know what Tug of War is, right? Or I like your thing with Troy where we flop everything. That's kind of what I'm thinking about, but I'm kind of where I don't know anything. Then do I fall back on some kind of super basic syntax rule, or what do you think?
I am. So, I'm not sure what would happen if you knew nothing. And I'm not sure if that is the right question, right? Because it's not like little kids know nothing.
Right.
They just don't know very much, and a lot of what they do know is like batshit crazy, right? They just have like completely wrong beliefs about the world a lot of the time. But I do think about this a lot in something related in sort of developmental research in general. Very often we assume when a kid can't do something, it's because if they can't. I'll give an example here, right? So like I've been thinking a lot about intuitive physics lately, and you like put like an object like this, and then it's very young babies aren't surprised when it doesn't fall, right? If I let go. The thing is, that's only surprising if you thought that the mass was sort of evenly distributed in this object. Which, like, if you're a baby, why would you think that? Right? It could be that all the mass is over here, right? So it's been interpreted as children don't know about gravity. It might just be that children don't know about remote controls, right? Which seems like they probably don't know about remote controls, right? And I think about this in a lot of language acquisition stuff too, where kids seem to be failing, and we say, oh, that's because they don't understand this like grammatical rule or whatnot. But often there's also like, we know that kids certainly, and adults as well, are using plausibility information to reevaluate what they're hearing, and I just don't know what the kids think are plausible. But this is the kind of thing that I am, when I said like, I was taking a step back from acquisition to think about, representation, like what actually is being communicated. It was precisely to set up being able to address those kinds of questions, or at the very least, like, if I believed that kids thought such and such, what would I expect them to do? And try to like work through like what the implications are there that we could then, go do targeted studies on. But I still haven't gotten quite to the point where I know exactly what it is that I want to try doing.
Yeah.
So if you have specific ideas, I would love to hear them. Right? Yeah.
So when you were talking, at one point I was thinking, well, someone else makes some noises, and I try, and I'm trying to figure out what they might be meaning, no matter what the words are. And I use the words to narrow down what those are. But in other words, I've already got pre-existing biases to what they might be saying. And this is just like the opposite of anything that's trying to take apart the language and looking at the pieces and saying, well, this is much how they must be doing it based on position or anything like that. So, I mean, and there's lots of ways of probing this. Like what happens when you're in a college class learning about something you know nothing about, or like the baby example, or the babies do know something. They know that people are know something about people, the world being full of agents of some sort or others, some of which are favorably disposed or something like that. But if I say, could you hand me that? I mean, that's like the ultimate. You have to have some idea of what I might be referring to be able to interpret that and act on it.
Yeah.
So, it just seems like there should be examples like that the large language models just will not be able to do. They might, if they can find something in existing literature that looks, it sounds like sometimes it has to be exactly like that, but you know.
Yeah, I think with large language models, it's tricky because, again, you want to be like it has to be something. I mean, with the new like multimodal ones, which are starting to come online, we may be able to do like, you know, some of this like pointing stuff or whatnot. With the, but I think what's hard is you want sort of a situation where they can't have just memorized it. And again, like with 500 billion words of input, it's just very hard to know for sure, like to construct examples that are like sensible, but not memorized. And this is why I like the fantasy worlds where we just like make up a new world that we're pretty sure people haven't talked about before, change the rules. But I wanted to pick up on something you were saying earlier, which is I do think that this is something there's, one point Noah Goodman and I were going to write something about this, but then, I don't know, pandemic or something. But I think that there has been sort of a trend, particularly sort of in the like Bayesian language comprehension field, to like move things out of semantics. Like by here I mean like out of the actual meaning of the word, and partly move it into like, you know, world knowledge, but also by just like loosening the relationship. So here, you know, I said like the utterance is a function of the message and the rules of the language. This is not like we're assuming something probabilistic, right? So it's not like, you know, you want to talk about your friend John, you know, it's very highly probable you will call him John, but you might call him James because, you know, you just a brain fart or something, right? And this actually starts allowing like certain kinds of things to happen, like successfully communicating with somebody while actually saying the wrong thing. Which, like, especially when you're teaching and working with students, that's actually part of being a good teacher, is knowing what they're saying, even what they're actually saying is gobbledygook, right? And that, I think, you know, in sort of very, let's call them like very rigid theories of sentence processing, that's often very hard to explain. And you see people trying to like back out and say, you know, well, actually the meaning of this word is actually, you know, much broader than it really is. No, I mean, like, here the claim would be like, no, John means John. James does not mean John. But sometimes people say James and what they're trying to communicate is John, right? And I think that, so like, you see this a lot in Noah Goodman's work, where you see just like a lot of things that were in semantics sort of like being handled through this sort of like looser connection between, you know, the literal meaning and what people actually say, which I think is cool.
I mean, there's a lot of times when people say, oh, yeah, John will take care of that. And like, they don't mean John will take care of that. It means that he won't take care of it. We know John.
Yeah.
And you can get that from the tone of voice, but sometimes you just get it from, I know that person, I know what they would say about John, they wouldn't say that.
Yeah, and I actually think this is why, like, I mean, teasing is a super interesting phenomenon, right? The fact that people tease their friends, like, say, like, that's an ugly outfit today, or like whatever, right? And I think probably social psychologists already know this, and this is, you know, not surprising at all, but it seems to me that, like, part of what's going on there is you're saying this in the comfort knowing that the person knows that you cannot possibly mean what you actually just literally said. And that itself indicates a closeness, right? Like, I believe you know me well enough to know that I do not actually mean this thing, I mean this other thing. Right? And again, I think that's something that's very hard to explain, like, you know, teasing or, you know, irony or sarcasm, if you have like a very rigid relationship between the words and their literal meaning. But if you, as you said, if what you actually, because again, I don't think anybody cares what words mean. I mean, we do, but, you know, like, I don't think, like, you know, when I take off my psychology hat and my, you know, psycholinguistics hat, then I stop caring too. What I care about is communicating with people, right? You know, literal meanings don't matter. What we're trying to infer is the message, right? Not, you know, we're not actually interested in the utterance itself. That's only, you know, a means to an end. Yeah.
So thank you for your talk, first of all. But on your conclusion slide, you mentioned that if you change your beliefs about how the world works, then humans would change their interpretation of that sentence, right? And so a model is C5 has trouble with that. And part of that might be because of the supervised learning issues that you mentioned. But has there been any work to understand what structure that internal representation of the world looks like in an LLM?
So people are working on that. I mean, and like, you know, God bless them, it seems really hard to me. I saw a paper that I have not read. Adele Goldberg is the last author on that paper that was looking specifically at Winograd schema and large language models and trying to probe like the model's beliefs about the world that they were using to interpret Winograd schema. I'm willing to believe something very exciting is in that paper, but turns out I had like this talk to prepare and I hadn't had time to do all the reading that I wanted to do. And my generative theory of the world leads me to believe there are people out there doing sophisticated stuff like that. I just have not yet read that work. Mm-hmm.
All right, so I have a preamble,
Okay.
then a ramble,
All right.
and then and then a question.
Okay, awesome.
So,
Love it.
so the preamble is sparked by your comments to Alan's question just a minute ago. So this kind of loosening of the relationship between the message expressed through the language and the interpretation of the message. This starts about a year and a half and is really very rich and robustly established by about 2.5. It's in pre-10 play, sure pre-10 play. So this is something that's really pretty basic. It's not something that comes, after peruse the internet to 5 trillion letter pairs or something like that. All right, that was the preamble. The ramble is, I did read Winograd. It was his thesis. I did read that in 1973, the year after it came out, and I used that to learn a program being taught to some of the algorithm. So that's the ramble. A little bit ramble. So now the question is, so right at the end you talk about this case where you change entirely the premise of the weak being weak now winning and so forth. You see that humans are very responsive to that, and the T5, the large language model, was not. That was a possible world semantic was much more like the human thing. So I'm wondering if is that, goodness knows, as you said, how language models really would work. But I remember being present at a talk that Jeff Hinton gave, but he was still a very young man, too. And this was very, very early connection with models. I had to be trained up with vast numbers of learning trials, and so
which probably was 1,000 back then.
Well, yeah. I mean, it was a very simple thing. It was just kind of, just a sort of small binary set of inputs, the binary set of outputs. There was only like 8 units or something like this. It was extremely small, even for toy model, but still needed hundreds. So a question from the floor, actually it was John Morton asked it. Well, this is very interesting, but if somebody were to come into the room now and say to me that my father's just died, I would immediately, I wouldn't keep churning through, happy listening to somebody telling me that several hundred times before I began to say that. I would immediately update. So that put me in mind of, do you think that you seems to me your Bayesian inference model is rather good at that kind of thing. I mean, it's updating. and it could update, presumably, if it's done it in the right way, on this single trial, but this changes everything. But by real humans believe. Is it that problem that John Morton all these years ago put to Jeff? Do you think that's the thing that this still the large language models have this inertia?
I mean, that would be potentially, consistent with the, what they're doing, right? I mean, as I said, like, these models are so vast. I mean, I remember this was like some years ago now when, people were like, oh, I have this neural network that has like learned how to do algebra without any symbols. And they investigated the model and actually had just like rediscovered algebra and was doing symbolic algebra inside, right? And so I'm always very hesitant to say what it's doing, but I will say, here's something that is definitely true, right? Which is that, part of the beauty of Bayesian models is, or really any generative model, is it can learn like blindingly quickly, right? Because like you change something anywhere and it like cascades through the whole system, right away. And neural networks just don't do that, right? At least in terms of like the updating weights or whatnot, right? Again, with transformers, it's weird because they have like quite a lot of memory. So there's like what they have learned in the context of the particular conversation they're having, which doesn't necessarily involve updating weights, right? But the flip side of this is that deep neural networks are very fast to get behavior out of, right? So they don't learn very fast, but once you got them trained, like it's not like you like typed something in ChatGPT and then come back the next day and see what the response is. Whereas if you had like a much smaller Bayesian model, you would definitely have to like go on vacation and come back and wait, and then maybe you'd have a response. Like they're just so slow to get responses out of. And this might be just like, funny facts about, Bayesian models versus, deep neural networks. Or it might actually be something, more profound, right? That is actually, these are like, the computational problem in inference is so different from the problem in learning that it's very hard to be very good at both simultaneously. And we may actually be, by arguing, is it like, Bayesian model, is it, reinforcement learning model, is it, a deep neural network model or whatnot, might actually be like the wrong sort of question, because you actually have a bunch of different problems you need your brain to do. And there are different computational problems requiring different kinds of systems. And we actually do have different kinds of systems lying around in our head for handling these different computational problems. If you're hoping for anything like more specific than that, that's what I've got. But it's one of those things that I keep thinking about, and it seems like there's something there, but I'm not quite sure yet where to go with it. Sure. I think we have time for one more question. Yeah.
I'm not from this world exactly, but sorry, I mean this scientific world. Not just but anyways, the large language model train on this gigantic corpus, and then they are in sort of a fixed state. That's what we're talking about. And it relates a little bit to Mark talking about contingencies. And it's kind of like you're saying, well, what if down was up, or what if weak was strong, so to speak. So one could imagine the model having a fantasy mode. And I don't know what happens if you say to ChatGPT, what if weak equals strong? Does it have a mode that can sort of instantaneously flip all the signs on something? Because your examples are pretty simple. So I don't know if one has to go to a full Bayesian confidence probability of something given that something to have a system that can update. On the other hand, in order to actually do anything what we might call creative, we're constantly thinking of counterfactuals, or what if I was wrong, particularly in science, what if what looks like is true isn't? And that opens up the possibility of accessing other kinds of information, or what we might call imagination, right? But it has something to do with contingencies and their implications for the machinery, for a kind of logical machinery. I don't know what I'm saying in some sense, but that's where I'm going. Does it have to be
Yes.
one or the other? Does it have to be
Oh, no.
versus whatever? Isn't there an intermediate mode? But more fundamentally, how many different modes of reasoning or accessing information do you need to have to create a human-like creature who's good at both types?
Yes. So a preamble and then maybe a ramble. So my preamble is what I like about computational modeling is not that I can like write down like my actual beliefs about how the system works and get numbers out of that, because like you pretty much never can, right? Like we just don't have the tech yet to do that. What I like is knowing for sure what the theory that I have actually implemented predicts, right? And so this is by way of saying, I have like, for the time being set things up as, these two very different things. But I think, as soon as you have like learning and caching, for instance, it gets a lot more interesting, right? So you say like we do like counterfactuals and whatnot in real time all the time. And I actually am not sure how true that is. Because I remember, this is good story for some of the younger people here. So I used to always, if I was giving a talk at a conference, this is like when I was just starting out, if I was giving a talk at a conference and they said, 15 minutes and 5 minutes for questions, I would give an exactly 20-minute talk. I would time it ahead of time because I did not want to have to answer questions on my feet. And I was like, I don't understand how these faculty must be super smart because they can dish on this stuff coming out of the blue, and then eventually I realized that this is actually not what's going on for the most part. You're answering questions you have thought about before, or thought about something, parts of it before, and maybe you're recombining those in real time, right? But you very rarely just get something so out of the blue you're like, huh, right? Whereas when you're very much earlier, everything is like, huh, right? And this sort of like starts allowing for, so I'm a big fan of Mars, 3 levels, the computational level, the problem you're trying to solve, the algorithmic level, what algorithms are using to solve it, and then the implementation level, like how to actually like build a machine that implements those algorithms. And again, here, there can be a looseness, right? So the algorithm might not be the algorithm that actually instantiates your computational description. It's an algorithm that does a decent job of approximating the thing that you were trying to do, right? So on the algorithmic level, right? So it might be that Bayesian models are beautiful descriptions, and like probable world semantics are beautiful descriptions at the computational level. This is the thing that we were actually trying to do when we were communicating with each other. I'm trying to condition your generative model of the world. You actually don't have a generative model of the world. You have something that approximates a generative model of the world, and you can approximate conditioning it. Or maybe you have a generative model of the world that you use for like long-term learning, but you can't use it in real time. It's just too slow. As I was mentioned earlier, Bayesian models are always just like too slow to actually use for any practical purpose, right? So what we might need, but if you start like caching lots of outputs, like remembering like, oh, this is what happens, when, a dynamo comes along and switches, what's going on, and try like, okay, well then I'm fast to like do that. And it's just like a lot of what's learning, a lot of development is actually not changing, in some sense, our beliefs about the world. Like the reason that kids get better at doing stuff is not because they've learned new stuff. They have memorized a lot of things, so they can respond quickly enough in situations where they couldn't before. I mean, it's just shocking when you play with the baby, you like do something and you're like, wait, okay, there's the response, right? They are just so slow to respond, right? And that might just be, something boring, like they just didn't have time to grow in enough myelin, or it might actually be, an important, interesting phenomenon, that speed up, which is the learning, and that is where a lot of the actually interesting stuff is happening, developmentally. That was a long yes, I think. It doesn't have to be. I think like as we get further in, the old dichotomies stop being interesting because we realize that's sort of like not the only option, right? Especially at like the algorithmic level, it's like made sense, at like a higher level to say like, these are very different, very different ideas. But like once you start actually getting to the implementation and you have the constraints of what can actually be done in real time, that changes what you actually do. and the list more complicated.
I think it was a plea for fact memory.
For what?
Fact memory. Good old-fashioned read-write memory where you can put in facts and find them later on.
I mean, that's fantastic if you can do the search. Right? That's the other, yeah. So caching is difficult because, yeah, the more stuff you have cached, can you do the search in real time? I think, like, so this is for, you know, sometimes I say it this way, that I think that Chomsky got the, like, performance competence distinction exactly backwards. All the interesting stuff is in performance, and the competence part's actually the easy part. Right? It's like, yeah, okay, it's like, great, you know the system, but can you use it in real time? And there's like really interesting constraints there that are driving, you know, what you can do.
That seems like a great place to end, and good food for thought for the reception. So thank you, Josh.